We want to see today what happens when I have negative numbers showing up in my exponent. We're going to call this the negative exponent rule. So let's remind ourselves real quick. Let's have a look. Maybe if we are just going to do this. 3 raised to the third power. What does this mean? This means that I have to take the base 3 and multiply it 3 times by itself. 3 times. This is what this number right here tells me I have to do with this base. We have seen also what this means, 3 raised to the 0 power. If I have a 0 exponent, that means that this will just turn into 1. Now, the next question that occurs is, well, what does it mean if I have a negative 3 showing up inside my exponent? What does that mean? I cannot say that this is 3 times or a negative 3 times 3. So what this will mean is the following. This means take the reciprocal of 3 and multiply that one 3 times by itself. So it has something to do still with multiplication by 3 times by itself, but not the original one, but the reciprocal. So if we are writing down this rule, then we have that for any real number other than 0, and if n is a natural number, that just means the number is positive, then I have that b raised to the negative n is the same thing as 1 over b raised to the positive n. So in other words, this thing right here just moves down there, and this negative number becomes a positive number. This whole thing goes into both directions. In other words, it's kind of like an elevator. This right here would move up if you would just think about it like this. Over 1. Over 1, this whole thing moves down and the negative number becomes a positive number. Here, this whole expression moves up and the negative number also turns into a positive number. So let's have a look at some examples here. For instance, if we want to write x raised to the negative 4th with a positive exponent, well, I'm going to have that x raised to the negative 4th. Let's have a look. We can think about it as if it is over 1, and that means that this whole expression right here, the x to the negative 4th, is going to have to move now into the denominator, and the negative 4 becomes a positive 4. And that is already it. So with negative numbers inside your exponent, it's kind of like an elevator. Either the whole expression that has the exponent which is negative moves up, or it moves down. And then the negative number turns respectively into a positive number. Now, we can now finally list an awesome list of numbers. Let's have a look. So 2 is in all of these instances the base. And up here I have my exponents. We have seen what 2 raised to the 0, 2 raised to the 1, 2 raised to the 2nd, 2 to the 3rd, to the 4th, and to the 5th means. Let's write down those numbers first. So this right here, 2 raised to the 0, is 1. 2 raised to the first power, well, that is nothing else but 2. 2 raised to the second is 2 times 2, that is 4. Now 2 raised to the third number, that is 2 times 2 times 2 is 8. 2 raised to the fourth is 16. You might notice the pattern. What happens now is 2 raised to the fifth is the same thing as this number multiplied by 2. So in other words, it will be 32. And now watch out. This is now where this becomes really cool. So if I follow this list now to the left, then I have this. 2 raised to the negative 1 right here. We have just seen that that means 1 divided by 2 raised to the positive 1, which is just 1/2. 2 raised to the negative second is the same thing as 1 divided by 2 to the positive second, and that is 1/4. And if we continue this list, you will see what happens. This is 1/8, this is 1 over 16, and therefore this is 1 over 32. So look at these numbers. Whoops, wrong tool. Look at these numbers down here. And notice these numbers over there. So the left side is just the reciprocal of the right side. This list of number is really useful, and you are encountering these kind of numbers all the time in real life when you, for instance, think about your cell phones. The storage capacity, that is. All right. So let's do a few more examples with negative exponents, and we always want to rewrite it with positive exponents. So we have 4 examples. Let's have a look at the first one right here. 5 raised to the negative third. Well, the first thing that I'm going to be doing is I am rewriting as 1 divided by 5 to the positive third. The negative 3 turns positive, and the 5 just jumps down into the denominator. And as a matter of fact, if it is something that I can simplify, in other words, multiply out, then I shall do that. 5 raised to the third power is 5 times 5, which is 25, multiplied by 5 again is 125. So 5 raised to the negative third is 1 over 125. Let's have a look at 8 raised to the negative 1. Well, same rule. 1 divided by 8 raised to the positive 1. Well, raised to the positive 1, this exponent of positive 1 isn't really very helpful. It doesn't need to be written down, so it's just 1 over 8. Let's have a look at something that looks a little bit more complicated. 4/5 raised to the negative second. I can do this in several different ways, actually. I have rules that said that if I have a parenthesis with an exponent, that the numerator gets the exponent and the denominator gets the exponent. All right, now I'm using my rules for negative exponents, and that means the 4 raised to the negative second moves down. It becomes 4 raised to the positive second. And the 5 to the negative second in the denominator moves up. It becomes 5 raised to the positive second. If you might notice something, that is the same thing as if I would rewrite this now as 5 over 4 raised to the second power. That will be a special rule that we are going to write down at the end of today, which I could. Finishing this off, 5 squared is 25, 4 squared is 16, and I am done. Let's have a look at the last example down here. 1 divided by 7 times y raised to the negative second power. I have to be careful. Only the factor with the negative exponent is to be moved. The 7 stays in the bottom. The y has a negative exponent. 7 has a positive exponent, the positive exponent of 1. 7 has to be left alone. It stays down here in the denominator. So only the base y is moving, and the negative 2 turns into a positive number. So now we are ready to simplify exponential expressions. Really, what this just means is, this right here just means use the rules. all of those rules that we have learned. So we are practicing all of our rules for exponents now. First, each base occurs only once. That means every variable for us is only going to show up one time. So let's have a concrete example here. In this case, 8x squared y cubed divided by 2x to the fourth y, everything raised to the second power. What this first step means is that I have to look inside my parentheses. I have x's in the numerator. Here is an x, and here is an x. That means the base x shows up twice. That can't be. I'm going to use my rules for exponents that say, a little bit of ink on the pen, there we go. I am simplifying the inside first. 8 divided by 2, that will be 4. X raised to the second divided by x raised to the fourth, we have seen that. That means top minus bottom, 2 minus 4. And y has the same thing happening. There's a y in the top and in the bottom. So I have y raised to the 3 minus 1. Raised to the second power. Now I am going to further simplify this. I have 4x to the negative second, y raised to the positive 2, 3 minus 1 is 2, everything raised to the second power. So right now every base shows up exactly one time, but this is not enough if I want to simplify this exponential expression completely. No parentheses. No parentheses. So first, each base occurs only once. And now we are opening up the parentheses. And you see what we have to do is just using the rules that we have learned before. The only additional thing really was this negative exponent, which comes in the last step. So I have 4 raised to the second, x raised to the negative second, raise that one to the second, y raised to the positive second, raise this one to the second. Everything gets the exponent of 2. And I further simplify. 4 squared, now that is 16. X to the negative second, raise it to the positive second. What do we have to do with these two exponents? They have to be multiplied. 2 times a negative 2 is a negative 4. All right. So I am still not completely done, because in the last step, what I have to still do is that we can have no negative exponents, or 0 exponents for that matter as well. So there is one last thing that we need to do to finish this problem off. I see that the base x has a negative 4 as an exponent. This needs to be fixed, and it can be fixed very easily. It just has to move into the denominator, and the negative 4 turns into a positive 4. The y raised to the positive 4th stays on the top, and I have now completely simplified the given exponential expression at the beginning using my rules. Each base only once, no parentheses, no negative or 0 exponents. Let's go ahead and do some exercises. 2 times x to the 4th, everything raised to the 3rd power, divided by 5x to the 8th. Now these rules have to just be used one at a time. So I see the first thing that I'm going to be doing, I'm looking at these parentheses right here, and I will open them up. So I'm going to have 2 raised to the 3rd, x to the 4th, raise this to the third divided by 5x to the eighth. In my second step now, I am further simplifying on the top. The parentheses have to disappear, and 2 raised to the third, that is 8, x raised to the 4 times 3 divided by 5x to the eighth. In my next step now, of course, 4 times 3, that is 12, divided by 5x to the eighth. Now I see that my base x is showing up twice, and I am having that this is 8 over 5 times x to the, well, top minus bottom, 12 minus 8. And that would be 8x to the fourth all over 5. I could write this also in this way. It doesn't matter for the homework assignment, just so that you get used to this idea. 8/5 times x to the fourth. These two expressions right here are the same. All right, here's another one, a fairly short one. X raised to the negative 12 times x raised to the positive second. So this is multiplication of variables with exponents, and what we are going to do with this, we have to add the exponents. It is always safe to put the exponents inside parentheses. That will sometimes help you, specifically when there are negative numbers showing up. So I have a negative 12 plus 2, that would be a negative 10. Now I still have a negative exponent. That cannot happen when I'm supposed to simplify. So I fix the negative exponent by simply moving the whole thing into the denominator. All right, so one more. I have inside my parentheses the expression x to the eighth divided by x to the fourth. Raise it to the negative fifth power. Now, here's one good thing to remember. I can always work inside my parentheses first. So if I do something on the inside of a parentheses right here, then that does not affect the outcome. I could have used another rule first, but that would have made my life maybe a little bit more complicated. So what I'm first going to be doing, I look on the inside. X raised to the eighth divided by x raised to the fourth is nothing else but x raised to the 8 minus 4. And that will be x raised to the fourth. Now I look at that negative 5 as an exponent on the outside of the parentheses, and in this case, what I have to do is I have to multiply these two exponents. So 4 times a negative 5, that will be a negative 20. And I now am almost done, only just like in the last example. The negative 20 has to be fixed. This is a negative exponent, and I turn this negative exponent into a positive exponent by taking the whole expression and move it into the denominator. All right, let's have a quick revisit of all of our rules for exponents. These are all of the rules. These are the ones that you need to know. So it will be very helpful for you to make a similar sheet of paper as I have prepared here for you. All right. The first one, b raised to the n times b raised to the m. What happened right here? You have to add the exponents. b raised to the m, all of that raised to the m power, you have to multiply the exponent. I'm not going to ever ask you what is the name of this rule. You just need to know what to do with exponents. a times b to the n. Yes, the exponent moved to both factors on the inside. b raised to the m divided by b raised to the m. Think about it. Top minus bottom. I have to subtract the exponents. I have a fraction and I raise it to some power. That exponent moves to the top and it moves to the bottom. b raised to the 0, that was just equal to 1, as long as b is not 0. Now we have b raised to the negative n. That turns into 1 divided by b raised to the positive n. And this last rule right here, that is the one that I have quickly mentioned at the beginning. b divided by a raised to the n power. I can simply switch the inside upside down, take the reciprocal of it. I switch the denominator and numerator and turn this exponent into a positive exponent. All right, make sure that you know what to do with exponents. Addition, multiplication, and subtraction is the only thing that you really do with them. Know when to do what.